slide, which was supposed to be there as like a waiting period, but I guess now it's the introductory beginning. So this is just some logistics we'll actually probably just get into at the end. So if we now go to the next slide. Welcome everybody to Competitive Programming Club at Rutgers. This is the introductory meeting. So we'll go over some of like an overview of what our club does, and then afterwards we'll look at a sample problem, actually the same sample problem from the involvement fair to give a general feel for what the problems look like, generally speaking. So going on to the next slide. We start at the beginning, which is what is competitive programming? So competitive programming
is you can stand there and then
I can? Okay. Sure.
Yeah. Okay. So competitive programming is fair enough. So you guys ever heard of LeetCode? It's a better version of that. So what we do here is we write efficient solutions to algorithmic challenges. That's a little bit vague. So more into depth, we try to, so problems are more, if any of you have done competitive math or just any kind of riddles or word problems, it's kind of like that, but you're translating it into code. So you're trying to find the most efficient solution to these kinds of problems. And it's a lot better than LeetCode because LeetCode, you're kind of just given a very dry and you know or you don't problem statement, whereas in competitive programming, you're generally given there's often multiple ways to solve a problem, and it's like, you're supposed to like interpret it and try to find the solution instead of just
to provide a more like concrete example of what all this looks like, a problem statement will generally ask you to take some input data and produce the correct output data, which will you run on the program that you make, which converts the input data into output data. The problem statement basically presents like a situation or problem setup, and then in practice, your job is to first think about the algorithmic approach, how you would do it. On an algorithmic basis. So this is before you even begin programming yourself. Then the second stage is when you actually implement the algorithm that you designed or came up with. Another, aspect to all this is that it is in a competitive setting, or a contest setting. So basically, the actual when you're basically racing other people to solve a certain amount of problems in the allotted contest time. So it's kind of like a game in that way, and there are, it's interesting because of that. It's like a fun experience. Then and then there are also two key aspects to making an algorithm or making whatever solution you come up with, and that is first figuring out how you would correctly interpret the input and produce output. And the second, which is also very important, is making sure that your approach is efficient, because when you submit a solution, you will be, your program is basically run on their input data. And if you are not careful with your algorithm, then if it takes like a too naive approach, then it will essentially time out. They have time limits on the amount of time your algorithm is allowed to run on. We will look more close at this in later slides. And finally, at the end, we have the assumption, which we will assume programming knowledge. So in practice, that's pretty much just knowing CS 111, how to code some basic building blocks, and we'll have some resources in Discord if you want to, figure some things out on your own, faster than 111 would do itself. So on the next slide, we have a common question, which is, what languages do I need to know? And basically, the three most common languages that are used are C++, Java, and Python. In the beginning, especially when you get started out with competitive programming, the actual language doesn't matter in practice. So we pretty much just recommend use whatever you already know among those three, or I guess there are other options, but these are the three that people generally are already familiar with. So then a note on that is that we will make our lecture implementations in C++ because C++ is probably the most, or it is the most commonly used language for this activity, since there are some subtle differences between the language. So the first difference, I guess, is that Java is noticeably faster than Python when you try to use it in this setting. So people, generally speaking, will switch from Python to Java eventually. So this is not an immediate concern for anyone, just like more like a long-term idea to know in the direction which you'll probably go. And the final one is that the switch from Java to C++ also occurs because there are some subtle benefits, some subtle things in C++ that make it more, I guess, compatible with competitive programming, make it easier to use. And that is the general discussion on the language. Now, why do we do competitive programming? Would you like to explain this?
Sure. So as I said in the beginning, we test our problem-solving skills not only just memorizing like what specific algorithms you need to do. It's also reducing problem, especially in like the workplace. You want to have like a very specific constraint. You have to reduce that algorithm to you reduce that problem to some kind of algorithm you can code and solve. So we test our problem-solving muscles here. And we got to think about problems from many different angles. We have a lot of discrete math, a lot of continuous math, although I'm kind of bad at that. Graph theory, algorithms in general. Those are going to be a lot of, yeah. So, and we teach common problem-solving tricks, especially in competitive programming and programming in general. You want to generally can't come up, probably not going to like just divine the solution in one just instantly unless you've seen the problem already. So what we typically try to do is find a brute force and then find commonalities, find recomputations where you're wasting computation, and then try to make it faster until it fits in the time limit. So yeah. The theory would be the theory would be algorithms, data structures, a lot of math. Well, yeah, I don't know. It's what you would expect from like a CS curriculum, I guess, in terms of like the more mathy side. And for implementation, you would we teach you how to implement clean and fast code because in competitive programming, speed is everything. So you would just get into the habit of writing fast and concise code. Yeah. Personally for me, it's helped me code 112. It's helped me code 112, 211, 214, all that a lot faster. Even if the topics don't necessarily correlate exactly with competitive programming, just having programmed a lot, having implemented algorithms a lot, it's just training that muscle. Yeah, you can solve interview problems faster. Pretty sure no one's surprised there. Yeah.
So that's like the leak code similarity, right? If you can solve competitive programming problems, there's a pretty high chance that you're going to be able to solve leak code and interview problems, which leads into the next slide, I think, of alumni at these places. So you might recognize these names.
I don't recognize them.
Yeah, so I mean, yes, question.
What's Google?
Google.
Good question. Good question. We should ask Google.
Yeah, so yeah, I mean, like in practice, I guess, especially for software engineering, there's immediate benefits that kind of come with proficiency in competitive programming.
A lot of money.
Yeah, but yeah, like I said earlier, it's pretty much the interview process becomes considerably more straightforward since, like, technically speaking, they're probably going to be able to understand all of the the problem solving aspects to any questions or most questions.
I can just throw in briefly. So when
Okay.
I interviewed with Facebook, every problem except for one that they gave me was like a sub problem of stuff I've seen at RUCP. And the one I didn't see was like a nice trick that involves like not using any overhead space, which is not something we do in RUCP very much because we care about asymptotic complexity, not overhead.
Oh, right. Oh, yeah, can you just handle Yeah, sorry. Yeah. Okay, so how do I practice for it? So how do we practice for RUCP, right? So, okay. For the beginner, so if you've never done competitive programming before, a great place to start would be the beginner lectures. It's roughly, I would say, what you would cover in an undergraduate algorithms course.
That's 344 in the CS department.
Yep. So if you want to, so you can get you gotta get a head start on that. And yeah, as we said, it's intended for people who've already programmed before. And we'll post, right. So how the beginner lectures are gonna work. So we're gonna have one topic 1 week, and the next week we're gonna have a practice contest on one topic. We're just gonna help guide you through we're just gonna help guide you through implementing some of the problems. We're gonna try not to give you ideas because the ideas are what's important, but in CP, it's a little bit weird if you've ever. It's not like object-oriented programming. We don't really care. We don't really care about that good software engineering practices. So you'll have there's some implementation details, some bugs here and there, and we'll just help you guide through that. But the main important thing is getting the idea across.
Yeah, so this is pretty much just more on that, where we will every other week we will alternate between the lecture and then a practice contest, which will generally align with the parts of the lecture. There will be some of like a mix also of the topics, so that because in an actual contest setting, you're going to see lots of different topics. So pattern recognition is a big thing to practice, and I think that's. Oh yeah, and then the mentor meetings. The mentors will basically be assigned in groups because fundamentally, one of the main events that we do every year is a team contest, which we will get into later. But yeah, so since some big contests are inherently team based, it's also a good opportunity to learn how to work well with others in this from this point of view of problem solving, algorithms, implementations, and so on. So that's mentor contest. So then there is the analog to the advanced people or advanced lectures. So
RUCP?
Yeah.
Come in.
So yeah, and then on Mondays we will basically have advanced lectures. This is probably best for people who are familiar already with the beginner topics. So that will pretty much look like anyone who's already familiar with 344, which is the algorithms class. If you've done competitive programming in high school, pretty much, there is the USA Computing Olympiad or USACO. If you've done that and have, say, gotten to the silver or gold division, then advanced lectures are probably appropriate. Of course, in the beginning, you can also just go to both and then see whichever one feels more appropriate. And that is that's the advanced lectures. Yeah.
One thing I would say is you definitely want to have done a little bit of either competitive programming or LeetCode before, because in the advanced lectures, some of the data structures are going to be pretty obscure, and if you haven't seen like the type of problem that frequently shows up in competitive programming, you wouldn't have an intuition for why we would use these kind of things. Yeah.
We have all the lectures on YouTube, so you can just see like the topics and click around and see which one.
From past.
Yeah, personally, for me, my freshman year, I did all the beginner lectures. I went to the advanced lectures, didn't understand any of them. It took me like a year, and then I started like doing the advanced lectures from all the recorded meetings. So
Also,
that's always an option.
we're also gonna have like some lectures in the next semester. So also, it's probably worth considering maybe redoing some lectures or having like a second pass at it to really make sure your intuitions are right.
Are they gonna be the same topics from last year?
They're going to be similar topics. There's going to be a lot of overlap.
We're for the fall semester, yes. For the spring semester, we tend to run out of lectures, so there may be some like really obscure,
Okay.
like lectures. Like,
Yeah, but and then I guess
I'd say the things that show up. I'd say the things that show up between years are generally the things you want to care about the most. Yeah, for the advanced lectures. Yeah.
Okay, so now to introduce Code Forces, which is one of the main or websites that we use for kind of managing this whole thing. So on Code Forces, one function of it is that it provides, on average, weekly contests. Sometimes it kind of like blobs up, and then there's like a 1 week with like a bunch, and then 1 week has nothing. But on average, it's about this frequent. The rounds themselves look 2 hours long typically, and they're 10:30 in the morning, something like that. And then you get some problems. It's a good contest to practice with. A way of and then there is a rating associated to your account. So you can think of it almost like chess, or exactly like chess, pretty much. Because if you perform better, right, then your rating would suggest your rating's going to go up. If you don't, it goes down, right? So that's the contest aspect of Code Forces. It also, on the very, very first line, there was a link to our group, which we will use for the practice contests. So like, it's basically a part of Code Forces that we kind of manage ourselves. Yes.
Hi, Mr. President. I'm too afraid to participate in contests because of my rating. What should I do?
Okay, so that's another, that is a good question. Lots of people have that, get tripped up in that early mindset of thinking that you first want to learn, you first want to understand some things before you start getting into contests. But that's actually not a very good way of thinking about it, because in practice, the only way the main way you learn is through practicing in actual contest conditions. So since there's a rating, there's you can think of it as having some stakes, right? There's stakes associated to it. But so you have there's contest pressure, there's whatever. But because of that, it doesn't matter what your early performance really is, because in the beginning, right, especially, you're trying to improve, right?
Yeah, you'll just get better. It's like any competitive game, League, Valorant, it doesn't matter. Yeah.
So and then a typical thing with rounds. Is that
Hi, Mr. President. What is a virtual contest?
Oh, virtual contest. That's a good question. So in Code Forces, if you go to the main site, you'll see that there's a problem set, which is basically an archive of lots of previous contests. Since it occurs so frequently, there's a pretty good archive. So because of that, you are able to basically mock a previous or past contest perfectly. There will be no rating, obviously, because the problems are already released and everything. But you will basically get the exact same layout. You'll see results live, right, as they were recorded as they came in during the actual contest, and you would see how you would place. You get the exact same experience, but again, not rated. So I guess if you want to do that before you want to actually get your rating involved, you can do that. And one more thing about the group. So the group on the first slide, it's also in Discord and one of the information forum channels. It's a link. And when you join the group, we use it for a couple of things. One is the practice contests. Another is, I think tryouts are done there, which we will get into a little later. And finally, there were just some set problems, sets of problems, which are very good for learning certain problem archetypes, which again, will be similar to the lectures or based on that. So finally, yeah, we discuss problems generally in in our Discord server. After the round, there's a whole channel devoted to it, and yeah, it's a good way to also interact with others, with everyone who's not. On the side, there's a I guess table of what the uh, rating system looks like. There's like colors and everything. There's like yeah, uh, it's kind of like chess. That's the best way to think about it. Yes.
I heard Joe is really good. Where is he on this?
Joe's really good. Yeah, so Joe is pretty high up
He's
there.
IGM.
Is he IGM?
Yeah,
He
he's
is, he is an
He got his
international
IGM back right after we released.
grandmaster. So yeah, Joe, who was the previous president, in Google Meet, I believe. Yeah. He
I know.
yeah, so he was international grandmaster, but everyone starts pretty much at newbie, which is pretty much unrated, and then just climb up with practice. And I guess the general rule of thumb, another thing is that maybe in the beginning it's good to do a bunch of easy problems, but you also want to do problems outside of the contest. You want to do difficult problems where you're actually learning, as opposed to using the contest or practice contest to actually practice, putting the pieces together, implementing it yourself, doing that whole aspect, like after you've learned the approaches that are usually used. Is that all?
Yeah. So one thing, just to add on a tiny bit. One thing to practice, I guess, one way to practice that Igor and we have discussed at this at length, like what is like the optimal time to read the editorial, which is like the solution. We recommend roughly about 30 minutes, right? And then you want to read the editorial like one line at a time and see how much of it you can deduce without much additional help.
Yeah.
So that's just like a good metric. And obviously, as you get better, you can decide this for yourself.
Yeah, so that's when you pretty much get stuck on a problem and you're completely stuck, you don't know how to do it, which is good because now you are probably going to learn something, right? So you can use in the future, which is, so that's why like doing a bunch of easy problems, right, is not going to help you, as much as struggling with new problems because that's time to learn, right? And that's another like common beginner trap, I guess. That's all we want.
Yeah.
So so the next main contest, which is arguably the main one that we kind of sent the club around, is the ICPC, the Intercollegiate Programming Contest. Basically, this is the contest where universities compete against each other. The teams that we send are of size 3, so I think we go to the next slide. We will have more details. Okay, here's the structure of the ICPC. Basically, there's a regional. We are in the Greater New York regional. It is a fairly difficult regional.
It's like one of the hardest.
It is, yeah. So in North America, right? Now, if Rutgers performs, well enough, the top team progresses to the North America Championship. That is now with all of the United States and Canada and some, I guess, other locations, North America. And finally, if you perform well enough there, you will, go to World Finals, which will be somewhere in the world, maybe close, maybe not so close. But yeah, it's like a thing that I guess you fly to. So I guess as a metric, last year or this past year, right? Rutgers, the top Rutgers team will be going to World Finals. So that is a result. So yeah. So now here's the I guess tabular list of the recent results of our regional. So a general upward trend, generally speaking, and yeah. So
It's worth commenting that like in 2020 and 2021, we were like pretty much the most dominant school when you like look at some sort of evaluation of like all the ranks. So like some other good schools.
yeah, like it's also a thing of not just like the top team, right, which is kind of the metric they use for like the cutoff to the next region, right? But it's also a thing of like volume, right? Like 2020, yeah, that's what 4 teams in the top 10. Last year was 5 teams in the top 18. So It's also like a volume thing. Like Rutgers seems, or yeah, maybe that way you will.
Is CMU at MIT in our region?
And
Our
that's-
regional, so yeah, our regional contains schools in pretty much Connecticut, New York, and New Jersey, and maybe some Pennsylvania.
It's like, if you look on the map, it's like just a tiny circle.
Yeah,
around
so
New York City.
yeah, because of population density. Yeah, yeah. So like I guess notable schools in our regional include Columbia, Yale, Cornell, Princeton. What else? I don't know. Ivies. It's those Ivies at least.
Mhm.
I
So
can just
that's-
I can just read off like the last results. Like there's Columbia, Rutgers, NYU, Cornell, Stevens, Yale, SVU, Poly.
22nd.
Yeah.
Yeah, then Yale again, Columbia, etc.
Now, ICPC is not the only contest that occurs. There is a yearly set that big companies do, right? Google has a Code Jam. Facebook has its Hacker Cup. It's actually an ongoing event. And basically, these are so people outside of college also compete in these. And that is so it's like it doesn't just end, after ICPC. There's like lots of ways to keep doing it. And also, this is also another good way to practice. The problems are interesting, and yeah, good practice. Yeah. So next slide.
Wait, I was gonna ask,
Yeah.
when does like ICPC usually take place? Is there-
Yeah, so the logistics. ICPC, so our regional, is probably going to be next semester in March, roughly. So we will have tryouts, right? Then a couple months before that, tryouts will basically be done through our like code courses group. And then it will be in person, right? So I think that's the current plan. So in the past couple of years, it was virtual for obvious reasons. But this next year will be in person. It's in Connecticut, and because of that, there will be like transportation things. So there will be like limits on how many teams we can bring. So that is also another purpose of tryouts, right? To figure that out. And I don't think that's all I wanted to say. Any other questions? Yeah. So then the slide. Yeah, very take time practice.
Oh, yeah. All right. Okay.
Yeah.
So,
So yeah. Speaking of practice.
hello. So this is the if you guys came to the development fair, we're just gonna go over real quick the solution to we're gonna walk you through the solution.
Solutions.
The solutions.
Multiple
Yeah, there's multiple.
But-
solutions.
We will go through them in like progressing like efficiency. So it will get, I guess, harder to understand, but like it should be fairly introductory.
Yeah.
So yeah, here.
Okay, so here's the sample problem. You're given a positive integer n. Find positive integers a and b such that a times b equals n and a plus b is even. Or determine that no such a or b exists. Constraints are n is less than or equal to 10 to the 18. Don't worry about that now. We'll get into that later. Anyone have a solution? I just say the optimal solution.
Well, you guys can do it.
No,
Go ahead.
It's divisible by 4, and you just divide it by 2, so the answer would be n over 2 and 2. If it's even and not divisible by 4, it's not possible. And if it's odd, it's 1 and n.
Okay.
A candidate solution.
That's okay. That's a switch. That's a switch.
I didn't want to just say it, because you guys knew I got it already.
So we will go through like the steps of like the intuition and everything. A like general idea here is going to be that with these problems, there's going to be like a series of like observations that you want to make, and then from that you want to like piece together what those observations like imply about the solution, and then reconstruct it from that. Usually. So
Just go on to
so
it.
we'll mention the constraints,
Yeah,
what that means a little later.
Yeah.
So
Okay.
yeah. So
So number one, brute force. with all the factors. A number can only have all its factors from 1 to n. So you just try all the factors and then see and just test the condition. Yeah.
So, so
And
there's some like code type stuff there
yeah,
where,
yeah. This is just implement programmer logic. If it's divisible by a, you know it's a factor, so you just set it to the other factor, and you just test the condition literally.
also just like a side note, which I think I forgot to say this. When we have C++ code on our lecture slides and everything, the implementations, it will be like, regardless of any language, right, that you use, Python, Java, C++, that will be readable, or at least readable enough to comfortably understand what's going on. Like, there are lots of parts of it which are practically identical between, especially Java and C++, and like this is literally the same, right? And also a sign on that side of this sign up is that there are templates which are an aspect to all this. Basically, a template is when you prepare code ahead of a contest. So it depends on the specific like rules of the competition, but most contests allow you to use code that was publicly available before it's, the start of it. So you're not just like memorizing implementations or whatever, right? It's like more about the problem solving, right? Figuring out how like the publicly available information fits with the problem, how you would implement it, all that. And so because of that, there are templates. Templates are, because so many people use C++, they are going to generally be in C++. So if you use C++, there's probably less work for you to do with that. Although we also probably recommend to really understand a template. It's also good to like make it or build it yourself, borrowing from other people's like code and ideas. So that was the sign about the code.
Okay.
Now on the next solution, I believe. This is just more.
Okay, I guess we can explain a little bit. We won't get too into it. You'll see it more as you start doing more code courses, and independent programming in general. So the problem with brute force is, well, first of all, it's brute force. But second of all, like the actual like nitty-gritty part is it runs asymptotically to O of n because you have to go through all the integers from 1 to n. So it'll take 10 to the 18 because 10 to the 18 is the limit for n. But we can only do 10 to the 8 operations competitive programming a second. So obviously that's not gonna work.
So just like to elaborate on that a little. So generally speaking, the standard time limit on your code to basically force you to make an efficient solution, right, is 1 second. And then based on that, right, they make their input size, like the maximum input size, right, determine or whether the problem can be solved in that time. The time, generally speaking, is 1 second. Like it's not always, so you sometimes have to be careful for like non-normal problems with that. But that's like the standard space complexity or whatever, all that, or memory. You don't need to worry about that usually. There are some like problem types where you kind of want to watch out, but usually you don't need to worry about space. Partially because a large space complexity sometimes implies a large time complexity as well. So that is the part where when you have 1 second, right? In all the languages that we use, that boils down to 10 to the 8 operations. So you can then like piece together the approximations on your algorithm, right? In terms of big O, which is just proportional to whatever as a relative to n, the input size. And just a note, it's not 10 to the 8th, it's like 10 to the 8th times like a small or reasonably small constant factor. But because of that, you usually want to play safe, right? And just make sure your algorithm is 10 to the 8th operations at most. So that is on that. So moving on to the
But you
next.
could do 10 of them.
You could.
I mean,
Okay.
Sometimes 10 of the 10.
Some.
10. I'm not
Okay.
Like Keith had a trick where you can do like 10 of the 10.
I mean, obviously it's not fixed because computer architecture and all like cache and stuff, but like
That's a good thing to mention.
no, it's really
Well, no.
it's really not. It's really not.
The thing I want to mention is that stuff doesn't matter usually because the algorithm is much more important than the actual tricks that you use to optimize it, right? I guess at a low level. And that's part of like what they teach, I think, when you learn Big O, right? That a supercomputer can't do n squared on like a certain input, but then like a regular tiny computer can just do n log n, right? In practically instantly. So that is kind of the point of having a very efficient algorithm, right? It's like really strong.
Yeah.
I think we both thought you were gonna talk about.
No. So that's what I said. Okay, yeah. So on the next slide, we go into the next. There's more. Actually, yeah. So this is a still a brute force method. This improves the running time. So before, remember, we were doing it proportional to n because we were literally testing everything from 1 to n. Now, the trick for reducing that to a smaller time complexity, which is root n in this case, root n smaller than n, that should probably be clear. We basically, when you observe that whenever you have a number that's divisible by two other numbers, one number will always be smaller than the square root, one number will always be greater than the square root. Because of that, if you only test every one of the first numbers, right? Because if you fix one number, the other one is now going to be an easy check, right? On if it works with the other factor to make a product that is n. So because of that, you only need to consider the square root of n numbers, or numbers, right? 1 to the square root of n in trying to find the a and b. And like on the slide, this is like a symmetric argument. So, are there any questions on that?
Yeah, does that make sense?
Okay. And now, here is the main solution, which you might have heard.
Yeah.
So, yeah, and again, I guess the simple tricks and observations are part of like the toolbox, right? It's like what you do to then figure out how to apply the tools that you already learned before. So moving on to the next slide, because we pretty much covered that.
Yeah, I guess. Oh wait, this one.
Observation we can observe. So the first, right, is so a general problem-solving strategy is to consider things in cases. So in this one, it turns out that the parity test or parity cases, so basically if the number is odd or even, allows you to figure it out relatively quickly for one case at least, and that is the odd case, right? When we have an odd number, we can just do 1 and n, because an odd number, 1 is odd, n is odd, 1 plus an odd number is an even number. And just like that, we're done with the odd case. Now, then there is the even case, right, which you have to now handle. Like I think we heard before, if it's a multiple of 4, we know that it will be divisible by 2, and n over 2. Since it's divisible by 4, right, n over 2 will be even, since otherwise it won't be divisible by 4. That's the logic for multiples of 4. And now, by partitioning into cases, right, we already eliminated lots of, I guess, a big portion of what possible inputs we could even get in the first place, right? So now if we check the final case, right, which is when n is even, right, but not a multiple of 4, we want to now think on how we would approach that. So I guess a couple slides here, we'll think about it a little on their own first. Does this all make sense with that? So now to review the final case, right? If a number, actually, so we have it there. Since we are forcing a plus b to be even, that means that they must be both odd or both even, right? Since if they were different, we know odd numbers plus even numbers are still odd numbers, right? And because of that, we can leverage the fact that basically, so now we exhaust the two cases in which our solution must, fall under, right? So now we have two cases from like the other end, right? From the solution. Either A and B are both odd or A and B are both even. Now, in the first case, right, their product, if A and B are odd, we still have an odd n, right? An odd AB. But if they're both even, we now can reason out that an even times even is a multiple of 4, right? 2 times something times 2 times something, right, is then 4 times something else. So it's divisible by 4. And because of that, right, if you remember, we covered both those cases already, which means that in the final case, there will never be a solution, which means that now, I think on the next slide, we now have a constant time solution. Because the observation here, or the reason why it's constant now instead of being proportional to n, is that we can do like arithmetic in constant time, which basically means in one step. So we can do all this casework checks, right, on if it's odd, even, on which case it falls under. That's all something that you can do in one step, right? You're checking if it's divisible by 2 and then divisible by 4. And because of that, it would be constant. It's basically instantaneous, almost. But it would be so quick, right, that it would be under the timer. Because if you remember, we had the maximum was 10 to the 18, which means the square root of an approach would have 10 to the 9 operations, which you can safely say is probably going to time it. So that is that problem. Or are there any questions?
So some of the like repetitive programming,
Yeah.
it's like timed, right?
Yeah.
So as long as you pass the test case within the time, it doesn't matter how.
Yeah.
the
So
solution is.
yeah, so the specific like actual like time that your solution takes is irrelevant as long as it passes a test case. Now because yeah, it's all about, because if you have an efficient algorithm, except for again some exceptions, you'll probably, if you figure out the algorithmic steps, you're probably going to figure out the main problem. Optimizations are generally not too necessary. And I guess a related point is that then is there like partial credit on problems if you get past some test cases and not others? And that depends on the context. I think Google Code Jam has like partial credit on problems, right? So okay, the way a contest looks is that you read a problem, right? You get them, you read it, you figure out the solution, you code it up, you submit it, right? They now show you usually the verdicts, right, on how they ran their hidden test cases, right? You can't like reverse engineer what they're doing, right? And hard code and everything, whatever. So then there's two different kind of archetypes on what can happen after that. If you get part of the test cases, but not all. So for example, yeah, Google Code Jam will give you partial credit on that, kind of proportional to the amount that you got. On the other hand, most contests, so ICPC and Code Forces and those types of contests, they will just be right or wrong, accepted, not accepted. That's it. So yeah, that is a distinction, but that's like more like a logistic thing that depends from contest to contest. Any other questions? Okay. So yeah, I guess here's the.
Yeah, okay. So we do this. All right, okay. So Mondays we're gonna have our.
Yeah.
So Mondays we're gonna alternate between advanced lectures and RUCP mingles. So just come and hang out, talk about stuff. I don't know. We have pizza there. That's nice. And every Wednesday we have the beginner lecture. So again, we have the actual lecture, and then we have the mentor contest every Wednesday. It is the mentor contest is 2 hours because that's how long a Code Forces round is. But if you guys have to dip early, it's no point in the schedule.
Or if you want to come late or you have to come late, that's also perfectly fine. Like we should have enough people to like put you in whatever group you want, or any group that's available. Yeah. So. And then so then the final kind of tentative big event, or not big, but like interesting event, right? Is yes.
Yeah. So we're gonna have Professor Asadi. He taught undergrad algorithms for me. So his research is in like what was it? It was like big streaming algorithms and like subletting algorithm. So it should be interesting. It won't be as much competitive programming as it would just be a theory talk. So if you're interested in that kind of stuff.
So that's like another, I guess, aspect, right? The difference between like, say, leak code and this, right? Is that leak code, or this tends to be more depth, right? The kind of relation to the theory of like computation, I guess, is like more prevalent, and it's more like, I guess, visible, right? The concepts go, yeah, it's more in depth, more mathematical. That's like a tendency, but yeah, so that should be it. We have a Discord server. If you're not in the Discord server, you should join it.
Why is it there?
Okay. Now, I'd assume everyone's in the Discord server because everyone's in this room. But if you're not, then you should probably join. Like, basically, any announcement is handled through there. The mailing list is, if you're in that, is just like part of the Discord server, right? There's also, if we go all the way back to the beginning, like the very, very, very first slide, this is my slide. Yeah, no, like before the title.
Oh, what?
Yeah, so this was the slide that was supposed to be.
Oh.
There's the groups link in Codeforces. You can make a Codeforces account, join our group. That is like a logistical thing, and that should be all for today. Do you have anything you want to add? No? Okay.
Yeah.
So any questions? No? Okay. So thanks for coming to the first introduction to RUCP 2022. And we hope to see you in the coming lectures. They will probably be recorded next time, so if you can't show up to them, that's a good day. And yeah, that's all.
Yeah. Any questions?
If you want to do the Codeforces thing now, we'll probably stick around for a little while if you need like help or something.
Oh, yeah, true.
But yeah, that's pretty much all I wanted to talk about today.
Yeah.
I know.